Alright, so in this video I'm just going to show how to go through these problems. I'm not going to go through and actually approximate them. I'm just kind of going to show you how to get you started on these. So let's look at the first one right here. Cosine of x is equal to the square root 3 over 2. Well, the first step is that we take the inverse on the left-hand side as well as the right-hand side. And the reason we do this is that we can get this x term all by itself, taking the inverse over here. So let's do that over here. And when doing that, these kind of cancel out right here and here. So you're just left with x on the left-hand side. So x is equal to cosine inverse square root 3 over 2. Whatever that is on the calculator. A lot of times, I think I should just mention real quick, whenever we write cosine inverse of this, it's the same thing as saying arc cosine of x, which some books notated as that, as well as arc cos of x, some notate as that. I probably, well, we're just going to stick with this notation right here. Alright, let's look at the next one. So this one we have to do a little bit of algebra right before. So we get cosine of x is equal to 1/2. Then we take the inverse on both sides. So we get x is equal to cosine inverse of 1/2. Then we plug that in our calculator. And we make sure on our calculator for here we're using radians, and for here we're using degrees. Now it says, what is x given in radians? I don't know if this picture should be here. What is x in radians given everything is in radians considering the picture below? So this is in radians over here. Let's just write SOHCAHTOA. So I know it's tangent, but let's go, the reason we're using tangent here, let's look at this angle right here. It's 2x. We know we have an opposite as well as an adjacent side, so therefore we use tangent. So tan of 2x is equal to opposite over adjacent. The opposite side is 10, and the adjacent side is 9. So then we take inverse tan on both sides. So we're left with 2x is equal to tan inverse 10 over 9. So therefore, x is equal to tan inverse 10 over 9 all over 2. We can type that in our calculator too. Alright, let's go over the unit circled. So, and this isn't a speed competition. When you're doing this, you want to make sure you just start going through and just checking off all of these at a time. I'm going to show you just probably the easier way to think of it. So we're at 0 degrees, we're at 0 radians. I'm just going to assume that these are all in radians. I'm not even going to write radians here. The only important ones that you need to know are this 30 degrees is pi over 6, and at 45 degrees it's pi over 4. And the reason for it is that 180 divided by 6 is 30, and 180 divided by 4 is 45. So now let's look at the 60 degrees out here. Well, we could go 30 degrees plus another 30 degrees to reach the 60 degree. So therefore 60 degrees is pi over 6 plus pi over 6. So the same thing as saying 2 pi over 6, which is equal to, divide the numerator and denominator by 2, pi over 3. And sometimes you'll deal with this one so much that you'll have that memorized. So this one's pi over 3. particularly though, when you go through and you start making this, you don't want to write, we're going to keep going around in terms of 60 and 45, but it's good to even think of it as 2 pi over 6 and then just simplify it to pi over 3. So let's just look at the 40. I know I jumped to the 60 degrees, but let's just look at the 45 going across here. So we're at, 1 second here. All right, so we're wanting to get to the 90 degrees. We see a 45 degree here and another 45 degree here. So right here, this must be 2 pi over 4, 2 pi over 4, or just pi over 2. Let's keep on going around. We add another pi over 4, which is 3 pi over 4. We add, I'm sorry about that. See, and it's okay if you use, it's okay to, you know that this should be pi, so it's not, I added 90, but we add 45, okay, so we're over here, it's 2 pi over 4. Now we add another 45 degrees right here, so now we're at 3 pi over 4. We add another 45 degrees, so now we're at pi. We add, or the same thing as saying 4 pi over 4. We add another 45 degrees, so we're at 5 pi over 4. We add another 45 degrees, so we're at 6 pi over 4, or 3 pi over 2. And then we add another 45 degrees out here, and we're at 7 pi over 4. Then all the way over here, we should land on 8 pi over 4. And the way we can check it is that it's 2 pi, because we know it's 2 pi, so that checks off. So that's the good. So now we went around and we did our 45 degrees. Let's pay attention to the 30, 60, 90 thing that's going on here. So we're at 30 degrees. We went to 60. We could add another 30 degrees. So now we're at 2 pi over 6, so this is 3 pi over 6. And then we add another 30 degrees right here, so we're at 4 pi over 6. We add another 30 degrees, so it's 5 pi over 6. And then we add another 30 degrees, so it's 6. So it's 6 pi over 6. And that checks off because we see the pi and pi are over here. Then what we do is we go, so we're at 6 pi over 6, so we go 7 pi over 6, 8 pi over 6, 9 pi, oh, I missed one. Right here is 9 pi over 6, 10 pi over 6, 11 pi over 6, and then we went all the way back around to 12 pi over 6. That should equal 2 pi, so this is our check. And 12 pi over 6, it does equal 2 pi, so that checks off. So we have this, we have all this scratch work, but we want to simplify things down a little bit. So how do we do that? So we'll erase this over here. So this is just pi. We have 3 pi over 4. We have 4 pi over 6. We can divide both sides by 2. The numerator and the denominator, we're both going to divide it by 2. So that's going to be left with 2 pi over 3. There's that one. We get 3 pi over 4. Let's see if we missed anything else. 7 pi over 6, 5 pi. 8 pi over 6. Let's divide the numerator and denominator both by 2. So we're left with 4 pi over 3. Let's circle that. This is the same thing as saying 3 pi over 2. Divide the numerator and denominator both by 2 over here. So you're left with 5 pi over 3. and then 2 pi, and we're all set. And then you go through it slowly and make sure you got everything. It's not a speed competition. I know we were doing competitions in class, but I want you to really make sure that you have it down, and you want to make sure you're checking off your key points. This is 0, this is pi over 2, this is pi, this is 3 pi over 2, and this is 2 pi. Going around that way. So that's a good way to check those. What's the trig identity we have been talking about in class for the unit circle? Important trig identity is sine squared theta plus cosine squared theta is equal to 1 squared, which is just 1. And this holds true for any value, any real number for theta. So what is sine of 0? The way I always remember this one is that sine of 0 degrees, sine starts at 0. So sine of 0 is 0. Sine of 30 degrees is equal to 1/2. Sine of 45 degrees is equal to square root 2 over 2. Just as a side note. And then sine of 60 degrees is equal to the square root 3 over 2. And just a notational thing, when I do a square root, I put that little notch on the end there, and that just helps me, if I have a big old quantity, like x squared plus 2x in there, that notch allows me to keep track of where I'm actually denoting this square root ends. So it's always a good habit to make sure that little notch is right there. Alright, so we know pi radians is equal to 180 degrees. What is 6 degrees in radians? Well, 6 degrees is the same thing as writing 6 degrees out like this. So we have 180 degrees is equal to pi radians. So the degrees cancel out, and we're just left with 6 times pi over 180 radians. And then I'll allow you to simplify it after that. What is pi over 7 radians in degrees? So we have pi over 7 radians. What's our conversion here? Well, we know we have radians down here. That pi radians is equal to 180 degrees. So the radians cancel out. Make sure it's over. That was kind of poor notation right there. So so the radians cancel out. You're left with degrees. So we have pi over 7 times 180 over all over pi. And then I'll let you simplify that on your calculator. Hope this video was helpful. I will see you later. All right, bye.